Hey, Mustafiz, what's up, guys?
ওলা হে
আহ, আলহামদুলিল্লাহ। আচ্ছা, ওই আমি গ্রুপে একটা এসএমএস করেছি, ওটা দেখো।
অন করে ফোন করে
Hi, everyone.
Hey. Hi, how are you?
Yo, hello.
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 Okay.
Hello,
Are you
Lashi.
ready?
How are
We
you?
begin to scan the QR code. Okay.
Okay. Okay.
All right, Lashi.
عندك التليفون عشان يسكن الحيطان السلطان صيفط لي راه وصلنا والو واش داخل
Okay.
هو
Please
النايس
scan the QR code.
اش من درت وصلت عندها اش من درت قول اش من درت وصلت عندها
Okay. Please scan the QR code quickly.
من درت no not yet miss not yet شنو هي الكونيكسيون تمر اللي عندي
Yeah, thank you.
It's done, Lashi. It's done.
yes I'm okay bro just send تيلقى شي تعويضات خونا
Bro, mute. We will start the lesson.
Are you okay? Okay. Okay. Please stay. Oh. No. Why? Oh. What's wrong? You are late because I can't produce a new QR code. I don't know why. No, because I click here. Yeah, but no response. Hmm? Copy what? That. What do you copy that? You say you're just late, right? Not absent. I don't know why you can't scan this QR code. This, I don't know this one. I don't know why. Please send your picture to me. Why you fail? Why you fail? Now scan it again. But your station is delayed. You fact you are late.
No, it's not my problem. It's people for
Office
Yeah,
problem?
they told me get that go.
Call me what? For what?
They told me
For what?
the dates.
I don't know. Huh?
This one,
Huh? Who is that? I don't know. You can spell it for me. This one? You say this one? No, but I think this only once. Only change it for you one time. Okay. Yeah, maybe you check this time. Alright. Oh, just calling to 19. Oh. COVID-19. This is your restaurant. Your username or your pass or your pass. Okay, only one. Okay, but we will scan this QR code for the second time tonight. I hope you know. Hello, everyone. We begin our lesson. Okay, and last time we have learned the separable or separation of variables, and we have learned how to calculate the first we review this. Okay, we learned the separation of variables. We learned to solve the differential equation like this. dy over dx is x plus 3x squared over y squared. And first we should and we learned to separate y squared dy. We separate x terms and y terms. And write y terms are on one side of the equation and x terms on the other. And then integrating, we get the general solution of this equation. Here, this is the separation of variables. We use this method just solve equation like this. But not every equation we can use a separation of variables. And then we learned another equation, another type of equations is the first order linear differential equations. Okay, first you should remember the form, the first order. This means the first just involve first derivative. So dy over dx plus like this. This is the pxy is qx. This is the first linear differential equation. Here, first order. This means first order. And the linear differential equation. This means dxy. This is iy like this. dxy plus iy. Here, I is the identity operator. Dx is the derivative operator. And then for solving first order linear equations, you just remember the integrating. You should remember integrating factor. Integrating factor. Here, integrating factor is E, is px dx. This is integrating factor. First, you find the first step. Please find integrating factor, and then you should multiply this integrating factor. Multiply both sides by integrating factor. Here, like this. Like this, we have this new equation, and then you should know the left side. This is really a complicated part. So, but this left side is the derivative of the product. This y times e px dx. So the equation takes the form. This means you know this is equal to d dx. This y e c dx is e c dx qx. And then this prime is equal to 1. So y e p dx is equal to e c dx qx dx. And then divided by e negative p dx. So we have this. But you know, it's really hard for you to remember this formula. So we just give you an example to explain how to solve first order linear equations. For example 1, in fact, we have solved it last time, but I think you have forgot this. So I will repeat it, and I hope you can understand now. Okay, here. This is a first order linear differential equations. Here, you should remember the form of first order linear derivative differential equation here, right? And from this, we find px. This time px is equal to here 2 over x, right? And qx is equal to sin 3x over x squared. This is qx. And then first step, we should find the integrating factor. Integrating factor. Here, integrating factor. Is we set the e px dx. This is integrating factor. And we write is equal to integrating factor is e 2 over x dx. So it's equal to e 2. We just find one integrating factor. So I just write is e 2 ln x, and it's equal to e ln x squared. The e and ln, they are inverses. So it's equal to x squared. This means the integrating factor is x squared. So the second step, I write here. The second step, we should multiplying both sides by the integrating factor. The equation is dy over dx plus 2xy is sin 3x over x squared. So multiply x squared by the square. We have x squared dy over dx plus x squared times 2 over x1 is equal to sin 3x over x squared times x squared, right? And then we simplify it. Just x squared, we write y prime plus this 2xy is equal to sin 3x, right? Sin 3x. We should remember the left side. Here, the left side is the derivative of a function, sin 3x. We should find this unknown function. We have a trick. How to find this unknown function? We should notice the first part of the left. This is x squared y prime. So a trick is find this unknown function. It's just you change y prime into 1 and find this dx is x squared y is equal to sin 3x. If you are confused, and I will prove why this prime is equal to the left side, we can prove it. I'll prove it for you. It's dx x squared y is equal to, y is a function of x. So I just write dx, this x squared yx is equal to here. This is the derivative, this is x squared product yx. So we should use product rule, and this means the first times the derivative of the second, so it's dy over dx, plus the second times the derivative of the first. The derivative of the first, the x squared prime is equal to 2x. And then we can write this x squared y prime plus 2xy plus 2xy. And I have put the left side here. The left side is the derivative of x squared y. Right? So I put 8. And then this term is equal to sin 3x. So we have this x squared y is equal to sin 3x dx is equal to this one. And now our target is to calculate this indefinite integral. Okay, we have learned it last semester, how to find this indefinite integral. Or find the antiderivative of this of sin 3x. Do you remember? This is negative 1 over 3 cosine 3x plus c. Okay, plus c. And we want to find the expression of y. So all divided by x squared. We have yx is equal to negative 1 over 3 x squared cosine 3x plus c over x squared. So this is the general solution of this first order linear differential equation. We have just got the solution. C absolute constant. We always write because C is an absolute constant, so we write C belongs to R. A real number. Example 1. Any questions? Example 1. Any questions? No. Okay, maybe you can try to solve example 2. Example 2. Example 2. Try to solve example 2. This is find the particular solution of d by over dx minus 3y is x is 3x. That satisfies y is 4, vx is 0. Okay, this is a particular solution. Example 1, here this is called a general solution. General solution. Here this is a particular solution. Because you should particular solutions, this means you should determine the number C. Okay, have a try. The first step, the second step. Okay. Okay. Hashimo, you give the general solution. Here we want to find the particular solution. Okay. This means this solution satisfies y is 4 when x is 0. Okay. Okay, I explained. Okay, here, first we should find the integrating factor, but you should know what's px and what's qx. So I write the form of the first order differential equation. And from this we know here px and px is equal to -3 here, and qx is equal to x is 3x. This is the qx. And the integrating factor defined is e p dx. Right is equal to here p is -3 dx. So right is equal to e -3x. -3x is the integrating factor. And then we multiplying both sides by e -3x to have e -3x dy over dx minus e 3y is equal to x e x. And by the properties of the exponential function, so this is x, right? This is x. And the left side is the derivative of function. How to find this function? We know this is e -3x. This is y prime. We just change y prime by y. This is the method. Y is equal to x. Okay, this is equal to x, and then we find here this e -3y is equal to x dx is equal to 1 over plus c. 1 over x plus c. And we find the solution y. So 1x is equal to 1 over 2x squared e 3x plus c e -1 over 4. This is positive. E 3x 1 over 2x squared plus c. Right. Here, this is the general solution. This is general solution. This is the general solution, but we want to find the particular solution. This means this solution satisfies y is for vx 0. So y is for vx is 0. We like x is 0, x0 left side is 4, x is 0, so this is 0 plus c. We have c is 4 here. We determine the absolute constant c is 4. And then we get the particular solution. Y is equal to 1 over x squared e 3x plus 4 e 3x. Here, this is the particular solution. This one. Let's see Lily's answer. Yes, right. Any question? No. Why we understand? Because here this is find the particular solution. It's not find the general solution. Find the particular solution, not the general solution. Understand it? Okay, next. Here, this is exercise. Here, exercise 1, 2, 5, 7, 8, 11. This. Just use the same way. First, you find the px, qx, and find the integrating factor. Yes, this is find the general solution because here this you can say 1, 2, 5, 7, 8 is find the general solution, but 11 here this y is 3, vx is 1. This means you should find the particular solution. Particular solution. Please have a try. First, find the px, qx, and then you find the integrating factor and multiply both sides by integrating factor and solve this equation. Okay, have a short break and we will scan the QR code for a second time later. Is your teaching?
হ্যাঁ তারপরে তারপরে মধ্যে গিয়া আরেকটা শব্দ বলে মিটিং মিছিল একটা শব্দ বলে বলতে আমরা তো মধ্যে ওদের ওরা গিয়া বুঝলাম তারপরে আমার জায়গাটা দেখি
Okay, please scan the quickly scan the QR code and then think about our questions. Quickly. Hello, everyone. Please scan the QR code. For the second time. Okay. 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 And can close it. Not working. Why? Listen to your picture, your result. Send a picture. Me. Why? Why it's not working? You have only 2 minutes. Except for you have only 2 minutes. Except for my time. Only 2 minutes to scan this QR code. Because we can say the students in our classroom have already finished it. They have done. And now I close. Okay, I close it. Okay. What's wrong? You have Mister. We have only 2 minutes. Okay. I do next slide. Maybe the third time you should be hurry up. It's always you have only 2 minutes. Listen to the picture. Yeah, but many students have scanned the code in 2 minutes. Why can't you? Okay, I'll give you I'll give you a chance, okay? Because we will scan the code for the third time. I change it. But we will scan the code for the third time. Yes, we don't have late. It's just the absent or present. Here you can say, I change your situation, this is present. I hope you can scan the code successfully in the third time. Okay. You can send your answer to me and I will check it. Okay, I see answers, Lily. Right. Yes, Barry is right. Okay, okay, yeah. 8. Right. 8 is right. Now 11. Yes, the last one. 11. Hello, and I will explain it, okay, one by one. That then is the which one? 11. Okay. Wait, one by one. The first one. Here is one. The first one. We can find Px is 1. So the integrating factor is E. P dx is equal to E 1 dx. We only find an integrating factor. So it's dx. And then multiplying both sides by ex. Ex 1 prime plus ex y is 1. And in the left side is the derivative of this fraction. 1 over ex is 1. And then we find here this is exy is equal to 1 dx. And this is x plus a constant c. From this we have y is e negative xx plus c e negative x. Okay, here this is the general solution for problem 1. Yes. Are you right? Okay, congratulations. Number 2, we can find Px is equal to Oh, here. Number 2, this is, which one? This is dy over dx plus, this x plus y times dy over dx, which the general form of the first order linear differential equation, like this. dy over dx, this is plus pxy is qx. So we should change the form of problem 2 like this. Here this dy over dx times 1, but here this is times x plus 1. So we change it, this is dy over dx plus x plus 1 y is x squared minus 1 x plus 1. We just divide by x plus 1. Divide by x plus 1. And here this is x minus 1 x plus 1. X minus 1. Yes, this. And from this we know tx is equal to 1 over x plus 1. Right? This is px. Yeah. This is the px. Here is the px. This is right px. And then we get the integrating factor is e t dx is equal to e 1 over x plus 1 dx. And we find this is e ln x plus 1. We just find one integrating factor, so it's x plus 1. Here this is integrating factor. Oh, number 2 right here. And multiplying x plus 1 here, multiplying x plus 1 both sides, we have this is x plus 1 dy over dx plus y is equal to x squared minus 1. Oh, just this. And then we can find this x plus 1 y prime. So write is d dx x plus 1 y is equal to x squared minus 1. Here we have x plus 1 y is equal to dx, right? Is dx. So we find this 1 over 3 x cubed minus x plus c. From this, we have y is equal to 1 over 3 x cubed plus c times 1 over x plus 1. You get this? Number 2, are you right? Here, number 2, are you right? Okay. Great, good. Do you understand it? No? Second, this one. It's just the same as the first one. Now, next, file number 5. You can take a picture. Okay. Quit. It. Okay. Let's see. Now, well, yes, well. Number 5. dy over dx minus y over x is equal to x dx. Here is number 5. And we can see, here we can see px number 5 is -1 over x. So the integrating factor is e px dx. The right is equal to e -1 over x dx is equal to e log x. Right e right. So we have this is equal to 1 over x, this integrating factor. And it's 1 over x, 1 prime minus 1 over x times 1 over x, y is equal to times 1 over x is equal to ex. So the left side is just the derivative of this. Replace here y prime by y is equal to ex. We have 1 over x, y is equal to ex. And from this we have y is equal to from this indefinite verb, this ex plus c. And then we have y is equal to x ex plus cx. C absolute constant. Right. C belongs to R. This one, are you right? Number 5. Are you right? These are the same, but the second line I had a mistake. The second line. The second line you make a mistake, but why the final result is right? Okay, and do you understand it? Okay. Quit. Okay. Quit it. Number 5. Number 7. right? Number 7. Almost the same, we find Px is equal to 1 over x. So the integrating factor is equal to E 1 over x dx. So it's equal to E ln x. We just find 1. This is x. Integrating factor x. So we have x, y prime plus x and y over x is equal to 1. And we have d dx. xy is equal to 1. We have xy is equal to dx is equal to x plus 3. So we have y is equal to 1 plus 3 over x. Okay, all right. Seven, are you right? Okay. You understand it, Seven? No. Here we just find the px is over x. Where we find the e? Where we find what? Where we find this? Where we find why this is x? This is we learned maybe last week. This e and ln they are exponential. They are inverses. They are inverses. Just like this. F inverse. No. F inverse. Fx is equal to x. So this is x. You see the same by 1 over x? Which one? This? How to find this ln x? This is yeah, yeah. The same way. No. E. Oh. Right? We write with E. And we length is equal to this negative or minus 1. So that is x. We have to see. X 1 over x. So it's 1 over x. We learn to the properties of the logarithm function. It's ln x squared, just like this, 2x. 2 ln x, just like this. This property. Okay. Seven. And here, 8. 8. Oh. This is last one. 3. Where is? Yeah, right. Eight. Yeah. The PX. Do you know PX here? Yeah, all right. Flower. One, please. 8. Are you right? I think you are right. 8. Okay. Okay, and I will quit it. Quit. Quickly. Okay, great. Okay, let's scan this QR code. Are you okay? Can I close it? Hello? Okay. Okay, I close it. Okay. We have only 11, right? 11, the last one. Last one. Here, we can say the last one here is px is equal to -1 over x, -1 over x, and we can find the integrating factor is e p dx is equal to e -1 over x dx is equal to e ln x. We have find ln one over x. Integrating factor. So here we have this is y prime is equal to 3x cubed times 1 over x. So here this is 1 over. From this we can say we can have this d dx 1 over xy is equal to 3x squared, right? So we have xy is 3x squared is equal to x cubed plus c, right? X cubed plus c. So have y is x4 plus cx, right? And then this is we calculate we find the particular solution. This means y is 3, vx is 1. Y is 3, x is 1 plus c. So we have c is 2. So the particular solution, we have y is x4 plus 2x. Are you right? Yes, well, right. Any questions for this one? No? Okay. Maybe we learn later about the inverse trigonometric functions and their derivative. Okay, no, we learn later about this. I hope you are familiar with the 6 basic trigonometric functions: sine, cosine, tangent, cotangent, secant, and cosecant were defined in section 0.7. And we have used them occasionally in examples and problems. We dip back to the notion of inverse. They are measurable functions since for each one in their range, there are infinitely many x that correspond to it. For example, we have x for minus x. Nevertheless, we are going to introduce a notion of inverse further, that this is possible based on a procedure called we will restricting the domain, restricting the domain, and the inverse sine and the inverse cosine. In the case of sine and cosine, we restrict the domain, keeping the range as large as possible, where insisting that the resulting function have an inverse. This can be done in many ways. The procedure is suggested by figures 2 and 3. We also show the graph of the corresponding inverse function obtained as usual by reflecting across the line, y x. This means we have learned sin x, cos x, tan x, cotangent x. I hope you understand. You are familiar with these 4 trigonometric functions. If we restrict the domain, for example, this is y, the curve of y is x, we restrict it from this one to this one. Okay, to this one. And then when this function is a monotonic function, and this means they have an inverse. Same, they have an inverse. We write is y is sine inverse x, sine inverse, sine x inverse. And here, this is the graph of sine inverse x. And for y is cos x, the restricted domain. The restricted domain is from 0 to pi. 0 to pi. Here, like this, 0 to pi. Restricted domain. And then we have the graph of this inverse. We write inverse x. Here, this is the graph of the inverse x. And now, calculate the derivative of this inverse function. Like this one. Here. Now, we formalize what we have shown in a definition. To obtain inverses for sine and cosine, we restrict their domains to negative pi over 2, and here 0, pi respectively. Thus, this means for this function, y is sine x, y is sine x. We have the inverse. The right x is the sine inverse y. X is sine inverse 1. And here, the restricted domain, you should remember this is from negative pi over 2 to pi over 2. We have this here. X, this is x belongs to. Here, this is for sine x. And for y is cosine x. We have the inverse. X is cosine inverse 1. Cosine inverse 1. Here, the domain restricted by 0, pi. Okay, 0, pi. Should remember this to encounter the inverse functions. And then the symbol arcsine is often used for sine inverse. This means we love sine inverse, but we give another symbol. We write this arcsine. This arcsine. And across is similarly used for cosine inverse. Think of arcsine. Arcsine as meaning the arc whose sine is, or the angle whose sine is. We will use both forms throughout the rest of this book. We usually use this one. We choose this one, and not this one. Okay, ready. And here we want to calculate. Example 1 is calculate A, B, C. First, you should know if y is f(x), its inverse. We write this. A new function is x is f inverse 1. Then we change the variable. We write y is f inverse x, because we usually use the independent variable. We always use the x, and in the independent variable we always use the symbol y. And also you should write first is verse and inverse function. We know if a point AB on the curve y is fx, because they are reflect across the line y is x, and BA is on the curve y is f inverse x. Y is f inverse x, just like this. You know, this is y is ex here. Oh. Here, this is the line y is x. This is the y is log x. You know, ex and log x, they are inverses. And if a point is AB on this line, you know, we have this BA on this line, okay, beyond this line. And here, this means if we want to find the value, for example, A, for A is sine inverse 1 to this one, we can write here, this is if AB, this means we write XA, the B is FA. Is FA for this one, and we have axis B. This is A is F inverse B, right? From this axis B, Y is A, right? We have A is F B. This means F inverse here, F the inverse axis, sin inverse x, right? Here, this means we know F inverse is equal to sin inverse, the square root of 2 over 2. We want to find A, right? This is B is just like this, square root of 2 over 2. Okay? On this point, so B, we want to find A. Here, with A, but we know A satisfies this function. Is B is FA. Here, F inverse is inverse x. We know Fx. From this we know Fx is sin x. Here, B is the square root of 2 over 2. This means B is the square root of 2 over 2 is equal to FA, sin A. Right? From this equation, we can solve sin A is equal to the square root of 2 over 2. We can find A is pi over 4. Right? Sin pi over 4 is equal to square root of 2 over 2 because A belongs to this interval. Belongs to this interval. Other question? Any question? I think I usually explain many steps, just one step by step exist or 超越怎么说？ Okay, maybe we have a break. No, our class is over. Okay, you should try to say this PPT after class. Bye bye.